So, continuing the applications of differentiation. Now we're going to have the concavity test. Okay, now what is concavity? Let's just say that you got something like this. The concavity is up, okay? And then if the graph keeps going like that, the concavity over here is down, right? So here you are, this is 0, supposed to be 0, okay? So it keeps being 0 here, and suddenly it does this. Right? So you see the concavity here is up, the concavity here is down. This is 0. Now, between this part and this part right here, the concavity is down. From here on, the concavity is going up. Okay? It's kind of complicated, and then you go, then you come, then you go, then let's just do this and this. Okay? Let's try that. So the concavity all the way up here is up. So we have concavity up all the way from up here. And in here, you got a concavity down. Okay. Let me think here. I want to show you guys this stuff. Concavity going up. And here the concavity in this part, the concavity is going up. Here's 0. The concavity is going up. Okay. So here the concavity is going up. At this point here, right in the middle, okay, it's not here, it's not here, it's right in the middle. The concavity changes and it begins going down. Why? Because here you have a tangent that's very negative, okay? This thing is like this. So you got a tangent that's very negative here, and then as it keeps coming, the tangent is becoming less negative, and then it becomes 0. So the tangent is increasing all the way up to here. When the tangent, so the tangent increases, as it gets down here, it starts becoming negative again. I mean, the tangent all the way from here to here is positive, okay? But at this point right here, the tangent stops increasing and it starts decreasing. So the tangent is decreasing now and it becomes 0. Now over here, you have a tangent that's continue decreasing, okay? Because increasing is like this and decreasing is the other way around, like that. Here. This is decreasing. So from here, in this part here, the tangent, well, it's increasing here, okay? It's increasing, and so it's decreasing here. It's increasing in this part, right? Why? Because over here the tangent is negative, and here the tangent is negative too, but the tangent becomes negative the most at this point. From here on now, the tangent starts becoming less negative until it becomes 0 again. So when the tangent is increasing, you got a concavity up. When the tangent is decreasing, you got a concavity down. Over here, I made a huge part here, which is just 0. So this part is just 0, okay? And then you have a tangent that starts going down again all the way up to here. So here the concavity is down, okay? Actually, this thing here, I'm gonna put it just a little bit more over here. It should be kind of like that. Okay. Oh, hold on. Like that. Okay. So the tangent is 0 here, and here it begins decreasing, and it goes the lowest point of the tangent here. So this part is also decreasing. From here on out, the tangent is negative, but it starts increasing again all the way up to here when it's 0. So for this whole part, it's up. And here is just 0, okay? At this point here, and then it starts increasing again all the way up to here. So when it's 0. So this part here is also going up, And this part here is also, well, this part here, the whole part is just 0. And in here, at this point, it's going up, and then it's 0 again. All right, so I'm going to show you guys something here. When you have a parabola, okay, the concavity is up. How do you know that? Well, find the graph of the first derivative. Okay, so what is a parabola? Let's just say that this is the function here with respect to x is x squared. So what is the first derivative? The first derivative is 2x. All right? So what does that mean? That means that when x is very negative, the derivative is going to be very negative. But as x increases, the derivative is always increasing. So make the graph of the derivative. If you're going to make a graph of the derivative, it'll be like this. It'll be 2x, right? 2x is going to be something like that. Kind of like this. So this is the graph, f of x. This is the graph of the derivative, of the first derivative, okay? And you can see that the second derivative, what's the second derivative here? It's 2. So the second derivative is always positive. When the second, that means that, you see, the derivative, the tangent of the graph might be negative at first, but it's always increasing, always increasing, always increasing, okay? So the second derivative is positive. So here's a little tip, okay? In order to find out if a concavity is up or down, what you gotta do is find out if it's a regional minimum, okay? So you come over here, you find the first derivative where it's 0. You gotta find this point. It's this point right here, okay? In here we're gonna have a derivative that's 0. Now, the first derivative test says that if the derivative to the left is negative and to the right is positive, at this part right here, you're gonna have a concavity up. Now, there's also something else that you can do. You see, the first derivative of this is 2x, okay? That means that the graph is always going to be going up. That means that you see here, the first derivative here, the derivative here is 0, okay? Now over here, what is the derivative? Not the derivative of this graph. I'm talking about what is the value of the derivative. It's negative, okay? Because everything that's below the x-axis, I'm sorry guys, everything that's to the left of the y-axis is negative. So to the left of x equals 0, you got a negative tangent. That's why the tangent over here is always negative. To the right of the x equals 0, the tangent is always positive. See, why is it positive? Because it's above the x-axis. Everything that's below the x-axis, right? It's a negative tangent. Everything that's above the x-axis is a positive tangent. So you got a tangent here that's negative, 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 but it's becoming less negative. See, it's approaching 0 this way. At 0, it's just going to be 0, and after 0, it keeps going up. It keeps going up and up and up. So you see that the tangent here is not always positive. The tangent of f of x, it's not always positive. It has some negative sides, but then it becomes positive. But it's always increasing. How do you know that it's always increasing? Well, you make the derivative of, you find the graph of the second derivative. So here you have the graph, okay, of the second derivative. And you see that it's 2. So the graph is this for everything. This is the graph of the second derivative. You see that the second derivative is always positive. Okay, so the concavity is up. So here's a rule of thumb. When you have f, now I'm gonna already showed all this stuff. Well, yeah, I'm gonna show it here. When you have f of x, which is 0, okay, and f, so not f of x, but f prime of x, the first derivative is 0 and the second derivative is greater than 0, the point that satisfies this stuff is going to be a minimum. Okay, so this is a minimum. Let me just see something here. Okay, now when you have f prime of x equals 0, this is called the second derivative test for concavity, and f double prime of x is less than 0, then you have a maximum. Now when they're both 0, f prime of x and f double prime of x, then you have to use the first derivative test to test. Okay, so let's just say, for example, over here you got you have an f prime of x is 0 here. Okay, it's the first tangent. I'm gonna use a different color, maybe green. Oh, sorry. Let's see if this green is good. Yeah, it's kinda blue. Good. So you have f of x, f prime of x, the first derivative is 0 here. Okay. Now, what is the this is similar to a parabola with concavity up. So what is going to be the second derivative of x is always going to be positive, because we found out here, okay, the first derivative of x is when for x equals 0 is 0, and the second derivative is always going to be 2. So you see that this is a minimum, right? Now at this point here, this is called the point of inflection. That's when the second derivative is 0, okay, and the first derivative is not 0. So here the tangent, you can see that the tangent here, it's not 0, but this is the point. This right here is the point of inflection. That's when to the left of the point of inflection, the second derivative is one sign, like positive or negative. And to the right of the point of inflection, it changes sign, the second derivative. The first derivative is not going to be 0, okay? So from here, I said the concavity is down, okay? So let's just say that, for example, you see f of x equals minus x squared. So it's going to be this part here, for example, okay? Now, what did I say? F double prime of x equals minus 2x, and f prime of x and f double prime of x equals minus 2. Now look at this. At this point here, what do we have? We have f prime of x, which is 0. Okay? At this point here, we have f prime of x, which is 0. And what is, for this whole part right here, just pretend that this is the function minus x squared. What's going to be the second derivative? It's going to be negative. So when the second derivative is negative, we are dealing with this part, and that means that the concavity is down, because this is a maximum, okay? It's a minimum here, and it's a maximum here. All right. Let me just erase this here. Now, at this point of inflection is going to be when the concavity changes from up to down, okay? So at this point of inflection, you have a first derivative which is different than 0, and the second derivative is going to be 0 here. All right? Why? Because like I said, if you're gonna, let me think here, I'm gonna make the graph. My goodness. This is messed up. Okay. I'm gonna make the graph of the tangent of this, kinda, okay? It's not very good. Just kinda. It's not perfect, okay? I'm just gonna try to imitate this here. So you have a very negative tangent, and up to this point here, you have a 0, okay? So it's gonna be very negative, and it'll keep coming up until it becomes 0 at this point. This is the graph of the tangent. Okay, and this right here is the graph of the function. All right, now over here, the thing comes up and up and up and up to this point, and when it gets to this point, it starts getting down and down and down. So it starts getting down and down and down, and it's 0 here. You see, this point is equivalent to this point. This point right here is this point here. You're going to understand later, all right? Now, the derivative now starts becoming negative again. So it starts being negative and negative and negative, and then it reaches this, it's going to keep decreasing, okay? The tangent here is decreasing, but at this point it starts increasing, so it's going to be decreasing, but at this point, kind of right here, it's going to start increasing, and by the time that it reaches this, it's going to be 0 again. So this point is equivalent to this point. This point is equivalent to this. Okay. Now, the tangent here is always 0, so it just remains as 0 here. And then in here, it starts becoming negative. It reaches 0 right in the middle, and then it starts becoming positive. Let me think here, it's negative. No, yeah. It's going to start becoming positive, become negative, negative. But then it starts becoming less negative, becomes 0 here. So at this point, it starts becoming more negative and more negative. It reaches this, and then it starts getting positive and positive and positive until it reaches 0. Okay. And now it's going to start increasing, 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 increasing until it gets to this point when it's 0. All right, so it's going to start increasing, increasing, increasing. When it gets to this point, it's going to start decreasing again, and it becomes 0. Okay, now it's 0 here, and it starts increasing, increasing, increasing. When it gets to kind of like that, it starts decreasing again and becomes 0. Now you got a bunch of 0 here, and then it starts increasing up to here, and then it decreases, and it's 0, and it finishes with a 0. Okay, now I'm gonna show something to you guys here. Here we go. The tangent is very negative until up to here. So I'm gonna put a 1 here, and I'm gonna put a 1 here. Okay, because it's kind of hard to see. So at this point, no, actually, let me think. This point, the tangent is 0. So the tangent is going to be very negative. So this is 1 here, because at this point the tangent is 0, this point the tangent is 0. And then it starts increasing up to this point. So this is going to be point number 2, and this is going to be point number 2. And now it starts decreasing until it becomes 0 again. So this is point 3, this is point 3. And now it starts becoming more and more negative until it gets to this point, and then it starts to become positive again. It's still negative, but it starts becoming less negative. So it reaches, this is 0.4, and this is going to be 0.4. Now it starts becoming less and less negative, becomes 0 here. So this is 0.5, and this is 0.5. So it becomes 0 here, doesn't matter. Okay, now here it starts becoming negative. So this is 0.6, so it starts becoming negative here. In the middle, right here, this is going to be 0.7, okay? It reaches the minimum, and then it starts becoming positive again. Let me think. No, hold on. I'm making a mistake. This is 0.7. Okay, 0.7 is going to be right here. You see what I'm doing? It becomes, it's 0, and then it becomes more and more negative up to this point, which is the lowest part here. But now it starts becoming less and less negative. So it's going up, it's becoming less and less negative, and it becomes 0 here at this point. So this is 0.8 and this is 0.8. Now it's becoming positive and positive and positive until it reaches this point right here. This is 0.9. This is the maximum that it reaches. This is 0.9. From here on now, it starts decreasing until it gets to 0. So you see, it starts decreasing until it gets to 0. There you go. Now, it starts increasing again until it gets to this point here. This point is 11. So this point is going to be 11. And then it starts decreasing until it gets to 0. So this point here is going to be 12. It's this point here. Now, it's 0, okay, and then it starts increasing again. So this point right here is 13. And it starts increasing, so this point right here is 13. Over here, because this is very tight, but this is good for you guys to see, okay, to try to understand how quickly these things change. Over here at this point, right in the middle, it gets to the maximum. So this is going to be the 14, and 14 is this peak right here. And then from here on now, it starts becoming negative until it becomes 0. So this 0 here is the 15th point, and it's over here. So this point here is the 15th point. Okay, all right. Now, what did I say? I said that in order to find the maximums and the minimums and stuff, what is a maximum? What is a minimum and a maximum, right? A minimum is when you have the first derivative 0 and the second derivative is gotta be positive. Okay. Now over here, when in this graph here is f prime of x 0, for example, at point 1 is 0. Okay. Now, what is the second derivative here? It's positive. You see that it's going up. The second derivative is going to be the tangent of the first derivative. The first derivative is the tangent of the second. The second derivative is the tangent of the first. So it's going up. Okay? So you have at point 1 in f prime of x equals 0, and you got an f double prime of x which is greater than 0. That makes it a minimum. That's why 1 is a minimum right here. Okay, now let's think about 3, for example, point 3. Point 3, I'm going to put it over here. Point 3, is the first derivative 0? Yes, the first derivative is 0. So you got f of prime x equals 0, and you have f double prime of x less than 0. Why? Because it's going down, see? So you got a negative tangent here. Now what does that say? When the first derivative is 0 and the second derivative is less than 0, you got a maximum. So in 3, you got a maximum, and look at that, you have a maximum at 3. At 3 you have a maximum, okay? Now what did I say? I said that the point of inflection is when you have a positive tangent to the left, and as you go to the right, the tangent becomes negative, or you have a negative tangent to the left, and to the right, the tangent becomes positive, okay? And the point of inflection is where the second derivative is 0. And look at this, the second derivative here is 0 because you got a positive slope in here, right? And then the slope starts becoming less and less positive, and it reaches 0 at this point. Okay, now I'm talking about the tangent of this graph. So the tangent over here is 0. So when the second derivative is 0, that's when you have a point of inflection. All right? If the first tangent or the first derivative changes sign, so you got a point here, at this point here, the second derivative is 0. Now you got to look at the first derivative. Is the tangent here positive and on the other side negative? That's a point of inflection. Is the tangent negative and on the other side, you see, let me think here. No, actually, I'm sorry. Oh yeah, okay, I'm making a mistake. This is confusing. The point of inflection is when you have the second derivative 0 here, and then the second derivative is negative here, positive to the other side, or positive here and negative to the other side. And you can see that in here. 2 is a point of inflection. Why? Because the second derivative is 0, okay? And the second derivative to the left is positive. The second derivative to the right is negative. So it's a point of inflection. Let's think about another point of inflection. Let's think about another point of inflection. 4. Okay, I know that 4 is a point of inflection because the second derivative here is 0. Now, the second derivative to the left is negative and to the right is positive. So it's a point of inflection. What is the point of inflection? Is when the concavity changes. So you got a concavity up in here. 2 is a point of inflection. Now you got a concavity down. Okay? 4 is a point of inflection. Now you got a concavity up. Now, here's something that is kind of messed up. Okay, is the second derivative, let me try to explain this to you guys. Is 6 a point of inflection? Look, at 2, the tangent is 0, so it's a point of inflection. At 4, the tangent is 0, it's a point of inflection. At 6, the tangent is 0, so it's a point of inflection. Wrong. 6 is not a point of inflection. Why? Because take the first derivative of the derivative, which is the second derivative of this graph. Okay? Yes, it's confusing. Now take the derivative here of this graph here. What is this? It's coming down. What about to the right? What's to the right? It's 0. Okay, so you had to have a positive here, not a 0, so it's not a point of inflection. What about 7? 7, is that a point of inflection? Yes, because to the left it's negative, it's a negative tangent. To the right it's a positive tangent. Okay, so to the left of 7, what I'm trying to say is that at point 7 here, f of 7, okay, the second derivative equals 0. If it's to the left of f of 7, which is in this part, the tangent is going to be negative. So how am I going to do this? I'm going to do something like this. Something that comes before 7, it's negative. And when you have something that comes after 7, it's positive. Okay, so it starts coming down here, then it reaches 0 and starts going up. That's a point of inflection. Is it a point of inflection? Yes, look at this. You got an arrow here coming down, and you got an arrow here going up. So the concavity here is down, the concavity is up. 7 is a point of inflection. Okay? Let's think about 8. What is 8? 8 is where the first derivative is 0. Okay, what about the second derivative? The second derivative is positive. Look at this. The second derivative is going up. It's positive here. So 8 is a minimum. Okay? So you got to memorize this thing. When the first derivative is 0, or it doesn't exist, because when it doesn't exist is also a critical point, you have to check it. Okay? So when the first derivative is 0 and the second derivative is negative, you got a maximum. When the first derivative is 0 and the second derivative is positive, you got a minimum. When the first and second derivatives are 0, you got to go back to the first derivative test. See if to the left is going up and to the right is going down of the first derivative. The first derivative here is going to be 0. So if to the left is going up and to the right is going down, that means that it's a concavity up and you got a maximum. If to the left is going down and to the right is going up, that means that it's a minimum down here. Okay, so that's when both of them are 0. What about the point of inflection? The point of inflection is when the second derivative is 0 and to the left of that point is positive and to the right is negative. Or the second derivative is 0 and the second derivative to the left is negative and to the right is positive. Okay, so let's just keep going here because they say practice makes perfect. I think it's more practice makes perfection, because perfect is an adjective and it's got to qualify a noun, so practice makes perfect what? I'd say it's practice makes perfection. Okay, so I say here that 9 is a point of inflection. How do I know that? Well, visually I can see it, but is it a point of inflection? Well, let's see. You can see that the second derivative here is 0, okay? To the left, the second derivative is positive, and to the right, the second derivative is negative. So it is a point of inflection. And is it a point of inflection? Yes, it is. Okay, I forgot to put I forgot to do this, but it is a point of, come on. It is a point of inflection here. The concavity here is up, but in this part here, the concavity is down. Okay? Okay, now from 10 all the way to 11. Let's see what 10 is. 10, you got the first derivative being 0. Okay? To the left, you see, this is why 10 is not a maximum. Is 10 a maximum? No, it's not, because you see, to the left of 10, the first derivative is positive, and to the right of 10, the first derivative is also positive. Okay? So this is not a maximum. This 10 here happens when you have a graph like this. You don't have that, okay? You don't have a peak in here. What you have is a little ladder that just keeps going up. So this is going to be a point 10, okay? Maybe this is going to be a point 10, this is going to be a point 10, point 10, point 10, point 10. All these are going to be 10. Okay, back to the blue stuff. Let's see now. Now from this point here, all the way here, what is 10? 10, you got the first derivative 0. Okay, and then you got a positive first derivative here and a positive first derivative here. So 10 is nothing. It's not a minimum. It's not a maximum. Is it a point of inflection? Yes. Yes, 10 is a point of inflection. How do I know? The first derivative, well, the second derivative here is 0, okay, because the second derivative here is negative, and here it's positive, and at 10 it's 0, so it is a point of inflection. See, this stuff in here, I'm just gonna do this and this over here. So the graph goes like this, which is something that looks like a concavity down, right? It comes, it comes, it comes, it comes, and then it becomes 0. And then it does this. You can see that this part right here has a negative concavity, and this part right here has a positive concavity. Does this look like a positive concavity? Yes, because if you keep going here, look. It's a positive concavity, all right? So, what did I say? 10 is a point of inflection. What about 11? Let's see. 11, you got a second derivative here, which is 0. So 10 is not a maximum, but it is a point of inflection. That's when the concavity changes from down here to up here. Now 11. 11 is a point of inflection because the second derivative here is 0, and you're going up to the left, and to the right you're going down. Okay, so is 11 a point of inflection? Yes. I forgot to, I'm gonna have to do this here. I have to do this. So here you got a positive concavity. In this space here, in this room, you got a negative concavity. I know it's tight, guys, but I wanted to make it tight to make it complicated, because this is complicated. Okay, what about 12? 12 you got, in 12 all the way to 13, you just have a bunch of zeros here, so it's nothing. Okay, it's just a flat line. Now from 13, what is 13? 13 is a place where the first derivative is 0. Okay, to the left is 0, and to the right it's positive. To the left is 0 here, and to the right is positive here. So 13 is not a maximum. Okay, in order to be a maximum, the first derivative had to be positive here and negative here with 0 here. To be a minimum, it had to be negative here with a positive here and a 0 here. Now 13, the derivative is 0, so it fits this and it fits this. Now to the left, you just got a 0, okay, and to the right you have a positive, so it's not a minimum or a maximum or anything. Okay, now over here, okay, I'm gonna need to make another yellow stuff in here, and right in the middle here I'm gonna put something, which is the point 14. Okay, this thing here I'm gonna change, I'm gonna move it here. Okay, and now I'm gonna make a negative here. You see, 14 is a point of inflection. It's going from a positive a concavity up here to a concavity down here. Now let's see about this stuff. I said 14 is a point of inflection. Is it a point of inflection? Let's see down here. Here you got a 0 second derivative. Okay, the second derivative is positive to the left and it's negative to the right. So the second derivative is changing sides, so it's a point of inflection. What about 15? Well, 15, you got a first derivative of 0. Okay, to the left is just 0, so it's just a flat line. So it's complicated, guys, I know. I'm going to erase all this stuff right here. And you also have to look, because all these things they're also related to when stuff doesn't exist, okay? When the second derivative doesn't exist, when the first derivative doesn't exist. So these are also critical points and you have to check them out. So, but as a general rule, when the first derivative is 0 and the second derivative is greater than 0, this is a minimum. When the first derivative is 0 and the second derivative is less than 0, it's a maximum. Okay, but also you got to worry about when the first derivative doesn't exist, because that's a critical point. When the second derivative doesn't exist, that's a critical point, blah blah blah. So okay, so this is called the second derivative test, to test for maximums and minimums. Now when you have the first derivative equals 0 and the second derivative also equals 0, then you don't know with the second derivative test. Then you have to go to the first derivative test. Okay, if the first derivative test, you got a point here, and you got at this point, the slope is 0, the first derivative is 0, but then the first derivative is negative here and positive here. This is a minimum. If it's positive here and negative here, this is a maximum. Okay, that's this stuff. Then when this happens, go to the first derivative test. The point of inflection the point of inflection is when the second derivative is 0, okay, and at a certain point, and to the left of that point, it's negative, and to the right becomes positive, or the other way around, it's positive and then it becomes negative. That's when it's changing concavity, from concavity up to concavity down, or from concavity down to concavity up. Okay, let me just think here for a second about something. Okay, let me just think here about something for a second. So here, the first derivative is positive, and then it becomes 0, and then it becomes positive. So the first derivative is positive, and then it becomes 0, and then it becomes positive. Okay, if you take the second derivative of this, hold on, I'm just trying to see if I can make this even easier. Second derivative is positive, then it becomes 0, then it becomes positive. This is concave. I'm gonna separate it here. This is concave down, and this is concave up. Okay. Now, this let me just think here. The second derivative is positive, and then it becomes positive again. Okay, so it's going to be negative here and positive here. Okay, so you see in this first line in here, so when you're changing from concavity down to concavity up. And this one's when you're changing from concavity up to concavity down. Okay, because this is a concavity down, this is a concavity up. And here you can see that the first derivative is positive, then it becomes 0, then it becomes positive again. So this is the graph of the first derivative. When you try to check the graph of the second derivative, you can see that it's negative, then it becomes 0, then it becomes positive. It's this case negative, then it becomes 0, then it becomes positive. Okay, and from a visual inspection here, I can see that this is concave down, this is concave up. Now let's just say that you had the other way around. You had something like this. Okay, I know it's not perfect, but it's incredibly imperfect. Man, I am not an artist. Okay, so let's think about this for a second. Okay, what is gonna be the graph of, so let's see here. It's incredibly negative, then it becomes positive, then it starts to become negative again. So it's like this. This is the graph of the first derivative. Okay, and seeing the tangent of the first derivative, which is the second derivative, you see that it's very positive here, becomes 0, and then it becomes negative. It's here. It's very positive, then it becomes 0, then it becomes negative here. All right. Now, what is this? Well, I can see going this way. I can see that this is concave up, and here it's concave down. You see why this is concave up? You're going to see, like, how do you know that? Because it changes, guys, right here. Okay. How do you know that this is concave up? Look. This is concave up. Okay. How do I know that this is concave up and this is concave down? How do I know that this is concave down? Look at this. Concave down. All right. That's how I know. I'm not going to do any exercises now because this video is already going very long, but you get this video in your head. You try to memorize these things in here, okay, because you're not going to really analyze this every single time. So you just memorize this. First derivative is 0, so it's a critical point. Of course, you have to analyze all the points that don't exist. When the first derivative doesn't exist, when the second derivative doesn't exist, these are also critical points, okay? Now, forgetting about the things that don't exist. When they don't exist, you just analyze them. But forgetting about the things that don't exist, when the first derivative is 0, the second is greater than 0, so it's a minimum. First derivative is 0, the second is less than 0, so it's a maximum. They're both 0, you gotta go to the first derivative test. You gotta see if it's a concave. I'm gonna do this as if it were a mirror, because this is left to right to me, but it seems that this is left to right to you guys, right? So you see that something's going from the left like this down and then up. So it's negative then positive. It's a concave up and it's a minimum. If it's positive then becomes negative, you got a maximum here and it's concave down. Okay? When it comes to point of inflection, what is the point of inflection? Is when you change from concave down to up or up to down. Okay? If you find the second derivative where it's 0. If to the left, the second derivative is negative, and to the right at that point, it's positive. So it's changing from concave down to concave up. If the second derivative is 0 here at this point, to the left, it's positive, and to the right, the second derivative is negative, then you know that it's changing from concave up to concave down. It's very complicated. As a matter of fact, it's good that I'm teaching you guys this stuff because I'm remembering all this. I mean, I studied this 5-10 years ago and I kind of forgot. So it's good that I'm teaching it to you guys and reviewing it at the same time. Yeah, so see you guys in the next video.